Hello friends, in this video I will be showing how to interface 7 segment multiplexed LCD display with 8051. Let's start. So friends, this is a schematic. Here there are 4 7 segment displays. Each input of 7 segment displays are connected commonly. That means you can see all A's are connected, all B's are connected, all C's are connected. So whatever the input I will be giving here will be common to all 7 segment displays, but it will be only gets on whenever the this transistor is connected to ground. This can be done only if I give 1. If it is 0, this won't be gets on. So at the first, suppose let's take an example. If I want to display 1 0 0 1, so at the first 7 segment display I want to display 1. At that time I will be keeping this first input as 1 and remaining inputs as 0 0, and I will give the required input here, which will make this 7 segment display as 1. At the next instant I will be making this one as 0, this one as 1, and remaining all zeros. Now I am selecting this finite number display, where I will give the required input, which will make this finite number display shows me 0. And then next instant I will make this one as 0 and this one as 1 and this one as 0. Here now I am selecting this finite number display, and I will give the required input, which shows me 0. And finally I will change this input also 0, and I will make this one as 1. And now I am selecting the last 7 segment display, and I will give the required input, by which I will be displaying 1. So here I am using the technique of multiplexing, where I will be selecting each 7 segment display at one instant of time, and I will give the required input, by which I can display my required output. But you may get a doubt that at all instant we can't see the LCD displays are not on at every instant. But due to the perception of vision, a human eye can't make a difference if there is any change in less than 0.15 fifth of a second. That means if any object is moving or changing its position in less than 0.15 second, then our eye can't detect that. So if I change these values faster than 0.15 of a second, then our eye can't detect that, and we can see all are on at the time, and we can see the display normally as you shown in the output result. Now let's start the coding. So this is the code. Here first I am initializing my DPTR value with my is the value where I have set all common anode values of 0 1 2 up to 9. I have initialized these values. Now I am taking timer 1 at mode 1. I'm I'm initializing those values to zeros. I'm taking register 5 as 0, and I'm starting the timer by using set bit tr0. Now first I'm making a bit. Now I'm making p3.1 as input bit, where I will be checking whether the bit is high or high. If it goes low, then my timer starts. Uh, First I am initializing these values R7 with 077. Uh, this is to set the value. So this is the multiplex LCD display. Here I have to select this is the positive. If I give 1 here, then this will be selected, and by giving the required inputs, this will on. So first I have to set the value, like 7 means it is the value 0 111 0 111. That means I will be selecting only this one, and remaining are off. For that reason I have taken 077. and I am having 4 LCD LCD 7 segment displays, so I have taken 4, and I want to store the status of each 7 segment display, so I am using R0 and storing the values in 10th location of RAM. So I am starting here. First I am taking R7, I am copying R7 to port 2. Now I am left rotating it and again copying to 7. Now I am fetching the value. So I am taking the status of first 7 segment display and I am copying to accumulator. Now I am fetching that value from DPTR to A and I am copying that value to port 1, and I want to make number to display for certain instant, so I am using delay. After that I am incrementing R0 and jump. I am going back until the 4 displays are completed. So here I am waiting until 1 second is completed, so I am using a loop. If so, here I am using the loop. I am waiting until I complete 1 second to increment my display value. So I'm using here the status bit of overflow. If there is no overflow, it directly jumps to this location, next file. Or if there is an overflow, then R5. If there is an overflow, then R5 value increments, and if the R5 value reaches to required condition, then it will jump to value. Then it will jump to value where my value get progressed. That means I will increment the value by using this conditional loop, and finally after incrementing I will again jump to my main loop and change the display value. So in this way I will get the required output. Now let's see how to implement this thing in Proteus. So here in Proteus, now I'm opening new project. Let's give it a name. I need a schematic. No need of PCB layout. You have to select the microcontroller 8051. Now we are finished. This is the layout or controller. Let's get the components. 7 segment. Common anode. Now let's make the connections. So we are done with the connections. Let us dump the code. Let's run the program. I forgot to connect the switch. Let us get that component. I need a ground connection. Yeah, we are finally done. Let's run the code. So in this way our LCD matrix works. So actually you can see here it is shifting each LCD segment and I am giving the data inputs here. So zeros are according to the selected value, the inputs will be changing, and this way 7 segment LED matrix works. For more interfacing videos, please subscribe my channel. Thanks for watching guys. If you like this video, please give it a thumbs up and share it. Thanks for watching. Please comment below.